You hear me now? Hear me now good? Hopefully. Hopefully you can hear me now. Okay, so this is Missile Command. We've been working on this not for very long. We replaced that one socket, it didn't help. So that sucks on the Pokey. But it didn't get any worse, so we didn't bridge anything we shouldn't have, so that's good. So currently, the bench test is set up, and what I have determined is that in the FPGA CAT software, my ROMs test good and my RAM tests good. So the connection between the CPU and all of these items is good. But for some reason, when we put the CPU in, now I don't have a computer monitor hooked up to see if with the FPGA CAT we're getting a good picture, which would be the next course of action. The next thing I want to test is if with the FPGA CAT, do I see the clock signal coming out of pin 39? Okay, so let me kind of go over the schematics here and explain to you where I'm at, okay? And here again, I feel like my face is too big. Anyways, okay. So currently the board is doing what's called a watchdog, where the CPU is just resetting over and over and over again, and that's usually because it's not getting the address repeat that it's supposed to stop to reset the watchdog timer so that it stops trying to reset. This is so if there's ever a bug in the code, it resets and it's good to go. So if I go back to this screen, I have my logic probe here, and if I use my logic probe, so if I turn on my test bench, so my board is now on. You can tell because there's a red light over here in the corner that you can't see, right here. And I probe pin 40, which is the reset line. See, up, down, up, down, up, down, up, down, up, down, up, down, up, down. So that means it's doing what's called a watchdog. It's just cycling over and over and over again. And that's because it's not executing code. And why it's not executing code, I'm not sure. But the first thing that I did realize is that if we look at the schematic for this, and I am going to ask your guys' opinion on this, but if we look at the schematic, we see the input clock is right here at phi 0. I assume that's what that symbol's supposed to be, phi 0. And phi 0 is supposed to be 1.25 megahertz, and it is. It looks perfect on pin 37. Okay, this looks fantastic. Now, my output clocks that come out of the 6502 look like there's no clock there. So it is just a really dirty, like 3 volt constant signal, 3 volt potential. So there's no signal here. And I'm not sure why that is, but my first thing I was thinking of doing is seeing if it's D3. I mean, if we take D3 out of the board, let's see if this signal comes back. Because it seems like this signal is being shorted somewhere where it obviously shouldn't be. And that is causing the entire read-write circuit to just be stuck at a 3 volt, like, floating idle weirdness. So, as I understand it, the way that this works is we get the voltage in, we get the clock signal in, the CPU runs, right? Then we take that and the CPU makes its own timers on phi 1 and phi 2, okay? Phi 1 and phi 2 are both the same 3 volt garbage, okay? But phi 1 on pin 3, I don't think it's actually connected to anything. Now, the schematics are pretty confusing. They just have symbols and say, oh, you're in here, because when Atari did these schematics for stuff like Centipede and Missile Command, they did this weird, like, grouped thing where, like, oh, this is the RAM section, and this is the memory section, and these things come into the memory section, and these things come out of... So it's not just one big schematic. I guess they thought it was easier to look at, but for me, it just confuses the shit out of me. Because then I gotta go, okay, where does BRW minus go? And then I gotta go through whole 3 pages of this document to figure out where else in the system this line is used, so I can figure out where it goes. If this was all just one big spaghetti mess, it'd be easier. Yeah, so that is the clock signal. Now, AI tells me that the watchdog should not be messing with this timer. This timer should run all the time when the CPU is on, okay? And the next thing I want to test is we have our FPGA cat here. And we've been putting that in and out of the system as needed. But I would like to know, because the FPGA cat is able to read the RAM and the ROM and everything, no problem. And I think that's because the read-write circuit here is independent of this clock. Okay, now it does rely on it here for this AND gate, for the minus read, which that does make it a little bit more confusing. But the FPGA cat tells me that my RAM tests good and my ROM tests good. Okay, so that means that the read and write functions are working, because the way the RAM test works is it writes a bunch of data to the RAM and then reads it back and makes sure it matches. And if it doesn't match, then it flags that chip as bad. So the read and the... No, not right now, Attic. We'll get to that probably today, but I really need to talk... The thing with the GBA is that we're working on Missile Command PCB right now, but there's no schematics or anything anywhere on how that thing works. So I really don't know, where to go with that without getting expert help. I need to talk to some folks. I need to do it on stream. Maybe you guys can help me figure it out. But anyways, we will get to that probably today. Now, so I want to see is if with the FPGA cat, do I see the signal coming out of that? Phi2. Do I see Phi2 and does it look good? And if it does, then we got to think about why an actual regular 6502 isn't working. So we're going to take this 6502 out. First, we're going to turn the board off with our fancy power switch I made on our first barn stream. And this is a brand new 6502. So the first thing I thought about is, okay, is my CPU just bad? And that's what's causing this. So I replaced the CPU, but no, the issue did not change whatsoever. So, and this was fully working like 2 weeks ago. And then all of a sudden it just decided to shit the bed. But I mean, I shouldn't be too surprised. This board was sitting off in a basement in the corner in a waterlogged, like not crawl space area, but, just like a cement floor basement for 40 years. And they couldn't even tell me last time it had been on. So I think it finally just, there's a chip on here that finally bit the dust. They're all original. Nothing has ever been done to this board. So we were bound determined to kill the logic chip, right? And I can't find my chip pullers. So we're just going to do with what we have. Or I'll have to go in the barn and get one. Or go in the garage. I had one. I might have taken it inside on accident. I'm trying my best. Is this going to follow me all the way over here? No, it lost me, didn't it? Where did it lose me at? Right there. Okay, I'm trying to get a good swap between, stuff out here in the barn and stuff in the house. But we're still working on that, aren't we? I had one hanging up here. I swear. Is it? Here. Get this thing in there. Not a big deal. So we'll put the FPGA cat back in to our 6502 slot. Okay. There it is. And it is the right way around. And it is the correct one, the 6502. And we can, here, I'll do this on this screen so you guys can see. I need to get a fan in here. It's hot. I need to get this space AC'd and everything. So, okay, so what we do with the FPGA cat is we're going to load. We load missile command, new, and then we open the port. And then we can turn the board on. And see, it sees the clock, which is rather jumpy. And I think that might be because it's resetting all the time, but something's not right about that. The clock shouldn't be jumping like that. You see how it says clock frequency in megahertz, and it's not steady at the 1.250. Anyways, if we go into these tests, oh, this one's failing on me again. Interesting. Okay, so I was able to remove this one and put it back in and get it to work again. Ah, okay, that one's failing again. So if we go to RAM, all of our RAM tech's good. Okay, and I am interested to know, that if I go back to the PCB and we check that clock again, it looks good, yes. Okay, so that clock looks good with the FPGA cat. It looks fantastic. It is 1.25 megahertz. Now it is switching off sometimes, but I think, and I'm about to show you something that I don't recommend. I need a better way to short this. Where'd the tool I used go? I used an absolutely enormous tool to do it last time. What did I do with it? Did I run off with it? I used my degaussing tool to short the clock. Or to short the watchdog, I should say. Where did it go? I must have literally just like walked away with it and flung it into oblivion or something, I don't know. But anyways, I'm very intrigued by the fact that that clock looks good with the FPGA cat. And I bet you, with the FPGA cat, if we put up a screen, the game's probably booted fine. So it's not working with a regular CPU, but it's probably working with this guy. So here's what we'll do. We gotta put this guy right here, ground it. We're making a redneck tool here. Yeah, there we go. No more twitch on the 1.25 if I hold this just right. So the watchdog is what's making that twitch, I imagine. It does look good though. So the cat is able to fix that. Now let me get you back to computer here. Okay, so that one at R1 is failing again. Now I got it to pass after taking it out and cleaning it and putting it back in. But now that it's failing again, I'm kind of sus. That's right, Michael, trying to preserve. Okay, so I'm going to turn this off, and we're going to take that chip out again. And if we have to replace this, I don't have any, and I don't know if I have a programmer that can program these, which is the sucky thing. But probably need to just replace this socket. I mean, all these sockets could be, especially because it's the one on the end. Probably has gunk in it, and everything else, but we just reseat that real fast. Can we get it to pass? There it goes. So it passed now. Okay. So it passed. Is our watchdog watchdogging? It is. But that might be appropriate for the FPGA cat. I'm not sure. So our circuit is still not happy. It's watchdogging, but the RAM and the ROM is testing good. The Pokey is not. Last time I tested the Pokey, it was not happy. It fails. But that might be because it's watchdogging. I'm not sure. I'm not an expert at this by any means. I wish I was. So, the fact that that clock works with the FPGA cat is very strange to me. But it doesn't work with the actual 6502. Why would that be? Now, if it was something pulling the line, I would expect the FPGA cat to also have an issue. What version? I don't know. The latest one? I bought this pretty recently. I don't think he's came out with a new one. Anyways. Here. So I don't know what else. There's lots of things we can learn on here by, doing analysis on different things. I haven't really gotten good at using this tool. You can do manual input output. The fact that this passes now by just taking it out, putting it back in is just so strange. So strange, so strange. I really wish. So let's run this one on repeat a little bit. So yeah, I think the RAM is good. The ROM is good. The ROM's flaky. Which is not, it's concerning. But that clock for read-write is good with the FPGA cat. And that might be because the FPGA cat is able to, is ignoring the reset. But if I ground the reset circuit and it's not resetting anymore, I don't think that signal comes back. And I don't think it's supposed to be interrupted by that. So we'll turn that off here. Okay. Let me think here. Now I gotta think. Let's turn this off. So the FPGA cat has told us that our one chip was bad again. So we fixed that. Now let's see if with that chip good again, if we're able to, that signal's back. If that signal's back, it's going to tell us we fixed that issue. Nope. So with the regular CPU in, that clock, the Phi 2, is just 3.8 volts steady. 3.9 volts steady, somewhere about that. It says it's got a peak of 4 volts. No frequency because it's just a constant signal. So why is that? If we look at the PCB again, that Phi 2 comes out and it goes to Phi 2 with this box around it, which means it's a test point. And then it goes out to Phi 2. I don't know where that goes. Okay? We'll just disconnect it. I don't know where that goes. I don't know why they do that to me. Because this stupid diagram's all split up. I don't know where this Phi 2 goes. I can sit here with the schematic for another 2 hours and look all around it and try to figure out where this is. Here, if you guys want to follow along with me, this is like the very last page It's page 61. Okay. So on 61 and 62, it gives you all the diagrams for this circuit. And this is the 6502. This is the main microprocessor. And this is the clock out. I'm assuming this clock phi 1 is just not used, considering it says pin 3 and has no connections. I'm going to assume that isn't used. Okay, but this guy should be out to a gate right here. It goes through a NOT gate at D3, and then it goes into a NAND gate at C3. Okay, and that takes you to read. And if you probe read write here, we probe read write, which is the other test point right next to it. See the same thing. Actually, this one you see absolutely nothing. You see 1 volt. Strange thing is, I hit this button a few times. The cat's gonna come in here and scream at me. Don't come in here and scream at me, cat. I'm streaming. Yeah. Okay. So these gates are ICs. These gates are pins on ICs. The NAND, the NOR gate is an LS14. I know that off the top of my head. An LS14 is a NOR gate. So if we probe the LS14, we see the same signal. If we probe 3 and 4, 3, we see the 3 volts, and 4, we see 0 pretty much, near 0. So it's correctly NORing the signal to nothing from 3 or 4 volts or whatever. But I don't know where this goes. I'm really worried about where this goes. This phi 2 that just goes out of the diagram. I don't know where you go, phi 2. I don't know where you go. So, let me move the chair over here, and we might sit here and look at this diagram, and I need to get my keyboard set up here. So, like, I expect phi 2 to be used in the RAM or probably in the ROM section. DRAM. So Yank asked what's the volts out of the gate. So going into the gate, we have wrong. Yeah. Yeah, we have like 3 volts going in, and like nothing coming out. Is that D3 or C3? What is that again? It's D3. It's D3. D3 pin. D3 pin. Oh man, I can't read that. 3 and 4. D3 pins 3, and then D3 pin 4. So if we D3 pin 3, I see about 3 volts, pretty steady. In pin 4, I see no volts. I see pretty much ground. Yeah, so I see 5 volts. Power to that chip rail looks good. Turn it off for now. What's missing, Strawberry Kitten? Hey, Matthew. Okay, so, thinking emoji. Why are we missing our clock, but only when it's an actual CPU? Why are we unable to create this clock? Dude, I'm not doing a backflip. You're out of your mind. Okay, so I'm just looking at the same diagram you guys are on my phone because it's so much easier for me to navigate it. So if anyone can find where Phi 2 goes in the rest of this circuit, I'd be really happy. But if you can't, that's fine. We'll just trace it physically on the board. Might be easier to do that at this point. Shit. Yeah, so let's do that. Dude, I am not... Do you see this? Well, you really can't. Do you see this room I'm in? If I did a backflip in here, I would kill myself. On a concrete floor, my fat ass cannot do a backflip. Okay, so if we go back to the PCB, let's disconnect. Here. We're going to flip this over. So Phi 2 is coming out of pin 39 right here. And it goes straight into 39. You know, I might also just think about replacing the socket for the CPU because, you know, I'm all messed up. I mean, they do tell you to replace the sockets just because they can be so messed up, but everything in here really looks pretty normal. That goes out to the blah blah blah. That is pin 38 right here. Right? 38. 39. 39, 39, 39. Yep, and that goes to pin 3 of D3. We see that right here. Yep, that's what it goes to. And it doesn't seem to go to anything else unless it's going to something on the top side that we can't see. Flip it back over here. Now I gotta fix all this shit because it's all tangled up because we flipped and flipped and flipped and... Oh god. Look at this mess. So 39, let's see if that's also connected to this guy right here. Is it? It is. So it comes down here and goes to a via. Where does that via go? That via is going somewhere. That via goes, that via goes to our test point that we're using, and it also goes out to the card slot here. So, I think that is what this means. What the fuck are you guys doing? I'm not doing a damn flip. Do a flip. This 31 here. This is the test. This is the test edge connector. So that's pin 31 on the edge connector, and this is where it comes out of our test point. I don't know what the fuck this goes to, and honestly, at this point, I don't think it goes anywhere. I don't think that goes anywhere. But I don't know. I can't find on the physical board anywhere else that clock goes except to pin 3 of D3. Can't find anywhere else that is going to. So, turn this back on. Let's probe around a little bit more, shall we? So, I actually did get the signal to come back for a second when I was testing, and I don't know what I did. I was just hitting the reset button over and over again. And it just came back for a second. I was like, oh, there it is. And then it went away just as fast as it came, pretty much. And I don't know why. So we should also see data on our address lines on 1, 2, 3, 4, 5, 6, 7, 8, 9. And we don't. 8. Nine, 10, 11. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They're all dead. The first one's low, and all the rest of them are dead. That is so weird. The weirdest thing about all this is that these address lines are being used by the FPGA CAT. So it doesn't make any sense that this shows them as neither high nor low, just disconnected. And we know for a fact our ROMs are not doing anything because they're not being accessed. Strange. I'm curious to pull up the D3, the 14N, and see if that clock comes back. Because it is the only thing it's connected to. So let's keep going from D3. We go to C3. It says 32. What the fuck does that mean? C3. C3 pin 5. 2, 3, 4, 5. Yep, and that's low. And that's connected in pin 4. And the output is 6. Well, that's not right. Oh, no, yeah, it is. No. Yeah, it is. Because if both are low, pin 4's low and pin 5's low, so they're both high, which makes the input yes, and the output is NANDed, so it's no, so it's low, so reads low. Just don't know where to go from here, because that's definitely a problem that clock signal's not there, but I don't know if it's our problem. You know, what else is making the CPU watchdog? The fact that it can't access code is definitely one of the reasons, and the fact that it's not making its clock is why it can't read write. But why is it not being able to read write? And why can the FPGA cat read write? The FPGA cat can... Oh, my camera stopped following me. That's okay. It's really not that big a deal, but... You don't follow me now? Over here? No? You're green like you can see me. Okay. It's the weirdest thing that I can't understand or can't comprehend is why the FPGA cat is able to make that signal, that clock, but our regular CPU is not able to make that clock. An AI told me that the watchdogging circuit should not stop the clock from clocking. How much do we believe that? I don't know. And we do have on pin 37, so 40, 39, 38, 37, we have a perfect 1.25 megahertz wave. Well, maybe not perfect. It gets hiccuped sometimes down to 6 kilohertz, which is strange. So we could follow our input and see if that's our problem, because our clock input is not very clean. It's not very clean. I see 1.25 megahertz, but I see it. So if we look at our 10 megahertz line, it looks rock solid, man. Well, it's got a little bit of a jitter, but not bad. And then our 5 megahertz line, also pretty good. Pretty rock solid. But if we go to our clock, measure it, damn it. There we go. Or I wanted it to, not measure. 40, 39, 38, 37. So hold that right there. Measure, auto set. Yeah, we get like little glitches in the clock now and again. I do have an oscilloscope. You can't see the data from it because I'm an awful streamer. No, just because I don't have the software hooked up to show you what it looks like on the screen. But it looks pretty solid. It just has little like half blips. And I don't know if that's because of the watchdog. I don't think it should be though. So if we go to computer, which you guys are still on, look at the timing circuit. So here's our clock in. It comes in from phi x and phi extend. So that's on C4 pin 1 and 2. So C4, let's look at that. So C3, C4, C4 pin 1 and 2. So C4 pin 1. Is nothing. Wait. Yeah, it's nothing, which it might need to be in pin 2. So it looks like the same thing. I see 1.25 megahertz like all the time with little blips down to half that at 625 kilohertz. So that's an OR gate. So the fact that phi extend is nothing means that we're just getting phi x out of this out of this OR gate, which I think is fine. I think that's fine. I don't know what phi extend is supposed to do. So phi x is the sync generated signal equivalent to 2h, except during the last 32 scan lines cities area of the video display. At this time, phi x pulses high on every other high pulse of 2h. Okay, there it is, clock extend. Microprocessor generated signal that when high delays the phi 0 clock input, holds phi 0 high to the microprocessor while sync is in control of the DRAM during the last 32 scan lines of the video display. So that is what makes the constant city at the bottom of the screen. So the fact that that is not doing anything, I think, is fine. Phi 0, sync generated signal controlled by the microprocessor, and sync, that is the base clock input to the microprocessor. So that's phi 0, which is our input. And if we go over here, I think the sync section's over here. Yeah, it is. So these counters do tend to go bad, and I keep being told that by certain people on the forums and everything else, but I'm never able to determine what is bad about them. So these counters are what kind of controls the whole sync display, and my game doesn't run, so I don't think it's a display problem. So we're not going to look at like vertical sync and horizontal sync because I do get a display, it's just garbage. What we will look at, shut up, multimeter, I want to ask you, is a phi x should come out of here somewhere. There it is. Here's phi x right here. So I'm going to start at, what is that, A8? Is that A8? Yeah, A8. A8 pin 6. It's the same. Looks like a signal that trips out every now and again. Okay, so from that, we will go back to A9. And that still trips out every now and again. But it isn't making my little it isn't making my frequency change. If that makes sense. Okay, so on that one chip, I sometimes see where my frequency on my measure will go down to like 600 kilohertz. But on that chip, it wouldn't do that. I would still see a little flaky on the screen, but it wouldn't, my frequency number wouldn't change. And, okay, so that's interesting. And what is between that and there? So phi x right here, that comes out. And that goes in right here to C4. So let's get them both on the screen. Can we do that? Right there. Okay. So we have this counter, and this is made by the 128, 64, 32, 5 megahertz. The 5 megahertz is good. So, and phi x out of A8, pin 8. A8, pin 8. Ah, that is doing that weird back and forth thing there. But A9 is not. Seems to be rock steady there. But it kind of flips back and forth on that one. So I might A8. That is a 74S00. I do have a 74LS00 right here. Wonder if that would change anything. Only one way to find out. Yeah, only one way to find out. What are these again? They're 1, 2, 3, 4, 5. They're 14 leggers. Let me get a socket. This is 7. Yeah, there it is. Okay, so we'll desolder that and replace it and see if it does anything, if that changes anything about our output. Let's try something, shall we? Might as well try something. Because on A8, my output of A8 has that weird jitter in the clock, where my input A8 and what was it? 9 and 10. Sorry guys, you're looking at the back of my head. What happened? There we go. What is, before we replace that, what is coming in on 10? Because 10 looks a little weird. Okay, so 10 is 1 and 2 out of this stuff. Out of A7 and B8. Huh. Everything goes back to the counters, doesn't it? 1H, 2H. Yeah, everything goes back to these frickin' counters at D5 and E5.
D. What are you guys looking at? You're looking at the schematic. D5 and E5. These two, oh, they're different chips. Really? Well, I guess so, yeah, they would be. Yeah, they would be. So, 14. And we can kind of tell if it's working if these just get quicker. That's so that'd be 16. That's D5. And then E5, 11. That goes up to 14. That's our counters. I would really expect them to get noisier. They really didn't seem to. I hate that they're on the other side of the chip, it's so annoying. So that's a 2.5, and that is 11 on E5, or 11. That's H blank. And 12 is going to be the super fast one, I think. That's 156 kilohertz. $312. Oh yeah, okay. Yep. So this should keep going up. $312. $625. 1.25. We go to the other chip, and we got, oh, that one looks weird. .156 kilohertz. $15. And that is pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 78. That's 78 kilohertz. 2, 3, 4, 5, 6, 7, 8. That's your first pin. Okay, that looks good now. A 15. And the next one is 15. What's going on here? So, in 11 and 12, oh, that's V blank, that's E, right? Yeah. That's V blank and 128H. So I think they're allowed to be the same. So, 12, yup, 13. 13 looks kind of fucked. It's changing a lot. $13 is 64. 64 is swapping between a few different frequencies, which none of the other ones are doing that. The other ones are all rock solid, but 13 is not rock solid. I don't think I have these chips though. These are these counters. Now we can try what's called piggybacking. Ooh, scared me. That chip is so pissed off. Yeah, I don't know. I'm gonna have to... I'm gonna have to, we can pull, you know what, we can just start fucking around. We can pull that chip and see if that fixes the issue of the switching, but I don't think it's going to, and that's because... Which one was it? 64H here looked kind of weird, but the weirdest thing is that the clock coming in on ZX here, it kind of sporadically changes between two values, which is 1.25 megahertz and like half that. So something's cutting it in half sometimes. And maybe that's supposed to happen and I'm totally barking up the wrong tree. That could totally be true. But as a first go, I guess I'm going to replace that chip because I have it here and see if that does literally anything. Hopefully we can get a clean pull on it. If we can't get a clean pull, I might have to go inside to do this because, and we'll probably just move on to the next thing. Because I don't have the hot air station out here. So we determined that that was... Ba-ba-da-da. We determined that that was A8. That's A8. Which is you right here. And hey, if we can't figure it out, if we just keep socketing chips, eventually we'll get it, right? Yeah. So hard to pull these chips out, man. Here we go. So let's make sure we didn't do any damage to the board. Now people think I'm senile. Okay, and we're gonna get a picture of that so that we know what connections there should be once we put the header on. Okay. Where did we put the header at? Right here. Didn't smash it, did we? Not.
Now this chip may come and go as it pleases. Thank God. We gotta get our solder. Should be around here somewheres. There it is. Cutters. I saw my cutters a second ago. They're there. Beautiful. Okay, let's check our other traces, make sure all our traces are good. Okay. Okay. And there was two that touched each other. Might have to remake that trace. It's the last two. These two, yeah. Saw that trace looked pretty bad. Okay. Can I do this without touching the other ones, is the question. I think I can. Oh yeah, I totally can. That's the bad thing about these boards, is there's no solder mask. Okay, seems good. That's good, yes. All right, does our board blow up now? I don't know, let's find out, I guess. Did anything change with that development? Anything change? Start over here. Not really. Let's see. But it still flickers, so it wasn't this chip's fault for that. That looks identical. Yeah, that all looks the same. So it's still doing that. I could totally be barking up the wrong tree, and that could just be how that's supposed to work. So I think I need to ask the forums. I need to take a little video, which I'll do right now, probably, of the flicker on this. So let me do that. That's good, yeah? Exactly. Okay, I will make a massive post about this tonight on Clove and see if anyone has any insight on what I should look at next. Oh, I do want to show them. When I looked at the timers, that one timer, which one was it again? That timer looks good now. Yeah, those timers are fine. Oh, it's because... 14? What's 14 doing on that one?
This must be doing something.
Hit 14. Well, my clocks look right now. My clocks look good. Just don't know what is causing the 0 to not do anything. So strange. So the next thing I want to try is I want to take off.
D3 here and see if the clock comes back. Because if it does, then we know it's something down the line here. It might not be D3 itself.
We know it's something down the line from D3 that's making the signal not do its thing. Right? Right. Right, guys, right? Yeah. Right, guys. Man, some of these chips are so dirty. It's kind of amazing that they work at all. Not gonna lie. Hi guys, what's up? Okay, so D3, which is this chip right here. Wow, there's a lot of them on there that didn't even want to suck out at all. It's just like, doesn't seem plugged up. Okay, yeah, this one's gonna have to be hot gunned. These are not coming out clean at all. Yeah, I think my gun's jammed up or something. Yeah, I'm gonna assume my gun's jammed up. I'll have to clean my gun and come back to this, but okay, we at least didn't make it any worse with today's shenanigans, did we? Oh, is that frozen? Is that cam frozen? Totally is. 'Cause the board's upside down and it's not in that camera, is it? Okay, this cam's not. Yeah, that cam's fucking frozen. There you go. I don't know what happened there. Anyways, let's get into the other section of our night. Say hello to the CRT out of the Game Boy kiosk. Okay. We get this set up in a way that is good. And here's the switch. It's unplugged. Good. There. Ah, damn it. Okay. So I shouldn't need to show you guys the screen anymore, so this is fine. That turned off. So this is our... Oh, wait, yeah. this is our CRT. Okay? And here's what I've learned so far about this CRT, is that it gets net low, and it doesn't, the high voltage won't turn on. And when I check the hot transistor, I only see 12 volts on, well, damn near everything. Like, the high voltage doesn't make it. So I went back to the power supply, and there's one pin of this power supply that gives out 75 volt. Okay? Now, is that how much the high voltage needs to turn on? I have no fucking idea. I can't find any schematics on this anywhere. This is a Hytron, this is a Hytron HVM2212 video monitor. Okay? So I have determined that it gets 75 volts in from this power supply. It gets 12 volt line and 75 volt line. $70 to 85 volts is okay. Okay, so it comes in at 75 volts from this power supply board into the neck board, would you believe? Okay, so first the 75 volts comes down here, comes into this board, and the first thing it does is run on a jumper wire up to this neck board. And in the neck board, it goes through a transistor that's called Q7, and that Q7 is a NPN. And the base of that, the switch that's supposed to turn it on and off, there's no signal there. Well, there is, but it's not being told to do anything. So if I follow that back down here, V1, that just goes into the control system, into IC1, into IC2, into all the madness that is the safety harness part of this PCB. So, I don't know. I did find one capacitor, this 330 microfarad capacitor that was shorted between the legs. Okay? Have you tried fixing it? Yes. That's what we're doing right now. We're trying to fix it, right? Unsuccessfully, but we're trying. So, right now it's off. And everything is in a way that it's not going to short anywhere. And if we're worried about it, we can put a bag under here. This is the easiest way that I can fuck with this, but also make it safe, right? So make it so you guys can see my multimeter. Can I do that? Can I position it in a way that you can see it? You can see that, can't you? So I should be able to turn this on in this state. Let me make sure I don't have anything crazy going on. Nothing touching off anywhere that it shouldn't. Neck board on the right way. Yes. Yes. Nothing touching off on anything. No. Transformer. Happy. Yeah, transformer looks happy. Okay, we have this right here. So we can on. And you get no high voltage squeal. You get no noise. You do see the heater come on in the tube. Yep, the heater is on in the tube. Pretty sure. Yep, I see it. The heater turns on in the tube. The big brown cap. Okay, Farm Tech. So, I was told about the safety cap. That's called the safety cap, right? The safety cap, I wasn't sure on how to test. Now, I watched a guy test safety caps in a Geo 7, and what he did was, I think he went to diode mode and went across it and made sure that it wasn't just shorted. Yeah, so I get no line between them that way. Farm Tech thinks it's the flyback. Yeah, I did inspect the board. So to give you a little bit more information, the fuse right here, fuse 2, was blown. So the fuse here on this board was blown, and when I replaced the fuse and turned it on, it didn't blow the fuse again. It just did this where there was no high voltage. Turns on, no high voltage. So something blew the fuse. The only cap I could find that was shorted was this 330 25 volt. That was bad. I have an I don't have one of those testers to test all the caps for the, the ESD, but yeah. So I'm not sure on that, but I reflowed a lot of stuff. Nothing looks particularly upset. Like anywhere where there's high voltage, I tried to reflow. I checked everything for continuity. You know, like I went through and it's like, okay, that's good. You know. I'm really thinking it's something in the control circuit here, like one of the ICs, or, you know, something else in the protection circuit. And if that's the case, I don't know how I'm going to track that down without a schematic. There's tons of test points all over the back of this board. It reads 100 volts, 106K. Wu Yang, 100 volts, 106K. 100 volts, 106K. So, we can take that out of circuit and test it, I guess. I'm really not sure what I'm looking for. I mean, it's just a capacitor. We can take a leg out and do a capacitance check on it and see if we get, 106 microfarad. We can also just do a full recap of this board and see if that brings anything back. I mean, they're old Daewoo capacitors. There could be more, shorts in the capacitors. That's just a lot of time and work to go through all those caps.
What was the reading of it again?
The reading of what? I'm sorry, Yank. What do you mean? And it could totally be the flyback, but if it was the flyback, I would think that it would keep blowing the fuse. The fact it's not blowing the fuse anymore, it's just not turning high voltage on. It could just be part of the protection circuit not letting the high voltage turn on, but I don't know. I would think that something catastrophic would be happening if that was the case. I did find on eBay someone selling this exact PCB, but they've cut all the wires off of it, including the wire for the flyback, for like $100, but I'm not going to buy that. That's ridiculous. So... The safety cap says it is a 100 volt 106K. So AI says 106K means 10 microfarad capacitance with a 100 volt limit and a 10% tolerance. Now I can turn it on and see if I see voltage on the non-ground side of the safety cap. If I don't see any voltage, then I probably have found something, right? I don't know. Turn it back on. I see half a volt across this capacitor. Yeah, there's just no power there. If I come down here to the hot, see 12 volts on the, what is that, the collector of the hot? 12 volts. 12 volts on the collector, yeah, that's not enough to do anything. And that's because the high voltage is not being let in by Q7 on the back of the flyback. But I don't want to just short Q7. Here, we can test Q7 real fast. Maybe Q7 is bad? Maybe Q7 is bad. The gas bug in the light. Do you see any caps with voltage 401 kilovolt? We off? Yeah, we're off. So there's two blue caps over here, and they say 393J. There's definitely no caps any bigger than our big orange guy here that's 100 volt. Definitely nothing bigger than him. The only closest thing is that blue one I just read you. It's 393J. That's what it says. So this is a C2 688. So it's an NPN. So if we go red on base, black to emitter, we should see and we see nothing. Red on base. Oh, that says typical pinout. I don't know if that's for sure this pinout. Yeah, I'm pretty sure that's it. Red on base, black to emitter. Red on base, black to collector. I have one of those little chip testers. I should totally use it on that. Because then it can straight up tell me if it's bad or not. Instead of doing this. I still haven't even taken it out of the box. I think it's inside of the house somewhere. I might go find it just to desolder this and test it real fast. There's a big resistor left side. Uh-oh. There's a big resistor left side where the wires go over. Is that okay? Resistor left side where all the wires go over. This diode here, there's a pretty big, that's probably like a 1/2 watt resistor right here. Are we off? Yes, we're off. How many caps do I have on this neck? 2 on the neck. I think I already tested this, but making sure there's no shorts on those. No, there's not. Okay. It's green. Oh, this thing? No, that's a capacitor on high voltage board. So there's a green one here, that's a capacitor. I assume this is what you mean by high voltage board. Oh, you mean this one right here, that's a capacitor too. Oh, I see it. I see what you're talking about. That is R48, which I wish I could find a schematic of this thing and know what R48 is supposed to be. Well, I guess we can know off the color rings, right? But R48. Sorry about that confusion there, my friend. He reads 100 ohm. 102 ohms. He looks like he's brown, black, brown, green. Brown, black, brown, green is 100 ohms. So yes, he's good. Oh yeah, Matthew, we can do that. We can just replace every single cap on this board. I mean, we can. We could totally do that. And hate ourselves and spend a lot of money on capacitors, and then probably it just still doesn't work, but I don't know. I did find one shorted cap and we replaced it. I was hoping that was going to bring it back to life, but it didn't do anything. So, I'm gonna go see if I can find that little tester I bought, and if I can find it, I'm gonna desolder this transistor. I'm gonna put it in that tester, and I'm gonna see if it tests good or not. I think that'd be. I think that'd be smart. So give me like 2 seconds. I'm going to be right back. Have my sponsor pay. Nice. All diodes okay? I mean, I didn't take them all out of circuit and test them. That's the hard part, right? Is even if I leave them in circuit, so if I leave them in circuit, here, let me make this so you can see it. If I leave them in circuit, and I'm in diode mode, so I see, like that's crazy in that direction. Oh, that was a capacitor. That capacitor is discharged now. So 0 that way. 0.358 that way. Look at that. Charges up and then goes to 0. I assume that's good. I don't know. This guy. Look at that. 0. Charges up to 0. Other way. Same thing. 3.5. So that's the 2 big diodes. There's another diode here. 0 that way. And half that way. That's more what I would expect it to be. Nothing in that direction, and like half a volt in that direction. Half a volt in that direction. Nothing in that direction. And there's another one. Another one here. Half a volt in that direction. Nothing in that direction after something charges up. And that's all of that. Yes. There's a little Zener over there, but. Oh, Jesus Christ. You guys are going to start on the keyboards again. I'm not going to be able to handle you tonight. The fucking keyboards. So I just don't know why this transistor isn't turning on. I kind of want to suss out him, considering he is where our high voltage stops. Our high voltage stops at this transistor and doesn't make its way to the other side of it. I could just short it. God, that'd be a bad idea though. That's probably a bad fucking idea. That probably will blow something the fuck up. If we short the collector and the emitter. Probably wouldn't be too happy, because the base isn't telling it to do anything. Anyways, so let me get that chip tester if I can find it real fast. No, I reflowed a shit ton of this already. I reflowed a lot of it. And I know that all my voltage is making it from this board. I see the 75 volts, I see the 12 volts. The 12 volt line's good. It actually turns on the lights and all the ICs get 5 volts. All that seems good. The only thing that doesn't happen is the high voltage never kicks on. So, yeah, let me get that chip tester and we'll see. American Panda says measure current to base. Current to base. Like amperage to the base? I'll let you guys type some shit out. I'll be right back. I need to get some water anyways. I don't think putting in the microwave is going to help. This is a little tester I got that I was talking about. So if we desolder that guy, I don't know if I might have to move the whole thing, which is going to suck. Actually, I can just get the extension cord. And I tell you what, I've really considered, if we can't figure out this missile command, to just sending it off to somebody who can fix it for like $100 or I don't know how much they charge. And him coming back and saying what's wrong with it, just so I can figure it out, you know, just so I know. Instead of me just clunking around like a buffoon forever. Waiting on that to heat up. Boo. Ah, it's hot. Ah, it's still hot. There it is. Let's see if this thing works. So we just put it in here, close the door. Okay, it says it's a BJT NPN. Base is on 3, collector's on 2, and emitter is on 1. So I assume that's a clean bill of health. This thing's kind of sweet. Got little parts in here and the button. Base is on 3 though. I didn't suspect that. Collector's on 2, emitter's on 1. Okay, now I gotta solder it back on. Everything's tangled, of course. So if that's the case, if I understand these correctly, the base is where the signal comes in, and the base is what's connecting my emitter and my collector. So the collector is where my 75 volts comes in. And then I don't see the 75 volts come out of the emitter. And that's because the base is not being charged. The base has to be charged to allow the switching out of that. So the base is connected to 2 resistors and a diode, and it's also connected to a capacitor. This guy, this 4.7 guy over here. And if we look at where that black, that's part of that stupid control circuit, isn't it? Yep, it is. So yeah, so we never see the 75 volts come out of that transistor. And it comes out and it goes in white. Does that make sense? Try not to short the 75 volts to the base. Yeah, shouldn't do that. So now that we have it plugged back in, I can show you. If we turn it on, make sure everything is how it should be. If we turn it on, is that all soldered in? Nothing shorted. Yeah. So we can turn it on, and if we get our ground somewhere, I think it's E here, we can see that this is our. Ooh, scared me that screen coming on. Oh, that's why. So yeah, 75 volts. See that? 75 volts coming in. Go across this resistor here. 73. And then it goes up into the center of this transistor. There's the 73. Our base is at 4 volts. Our base is at 4 volts, and our output is at 3.5. So our base is sitting at 4 volts. We don't know why. Why is that? We got nothing coming in on here. Okay, let me check something here. Turn this back off. So there's a resistor that connects the base and the collector to give the voltage required. It is what looks to be brown, green, orange, white. So let's take the neck board off here. Because I think it's supposed to be 5 volts on that, and it's only getting to 4. Usually 0.7. See, American Panda understands transistors. I, with a master's degree in EE, don't understand. Boogie, I do key, will you pay GTA 6? Maybe. Will you wear wigs? Will you? Do you have wigs? Will you wear wigs? From base, check backward for volts. Yeah, so, from base, check backwards. Oh, okay, so the base, there's not really much backwards to go. The base is connected to a capacitor that goes to ground. It's connected to a resistor that comes from 75 volts, and it's also connected to a resistor and a diode that go to ground. Or to one of the control lines. I shouldn't say ground, it's one of the control lines on the main PCB. Which is why I'm thinking the voltage isn't getting high enough because the main PCB safety is not allowing that voltage to go in. Because that voltage is the black line. What's it labeled? G. Yeah, G. And that goes into all this clusterfuck, where there's 3 other transistors, and there's connections to the IC1 and IC2, and there's resistors everywhere, and it's just a complete and utter mess. And that is at 4 volts. So, yeah. Let me see if my high voltage makes it over here to H. I'm kind of curious. I mean, okay, so that's all happy. We can turn it back on now. That's where you must check. Okay. We'll check that. Give me 1 second. Let's see what this is. Here. 12 volt. Okay, that's our 12 volt line. I got you. Or that's supposed to be our high voltage, and it is 12 volt because it hates me. Because that goes through a big resistor. So what is right here? 73 volt. And then it goes through some inductors. 73 volt. There's a capacitor here. Yeah, that separates that to the 12 volt. It's down here. Some millivolts. A 72 volt. Right? Yeah. 72 volt. 72 volt. Yep. So the 72 volt does make it to this pin right here on the flyback, which is probably what's turning on our heater coil and all that goodness. Let's see, does our 72 volts make it out of this neck board anywhere? I don't think so. I think this transistor is our... I still think that this transistor is our problem. But it could... Because, I mean, the collector has 72 volts going to it. If it's got 72 volts going to the collector, an American Panda might be able to answer this. If it's got 72 volts on the collector, then the emitter should be 72 volts when it's on. Should be emitting that. Okay, I'm gonna check that resistor like I said I was going to. Turn that back off. Let's go to resistance. Hello, I'm throwing shit. So that's a 10K resistor. Is that what it's supposed to be? I don't know. I have to read the color lines if they're still there. But it's so old, I might not be able to. That is like an 800 ohm resistor. There. And then there's a diode next to it.
going to show continuity both ways because there's a resistor right next to it. In line with it, I mean. About this guy. That diode at D11 is sussing me out. I mean, but the voltage is there, so I don't think... That can't be a problem. Okay, if I have 75 volts... Let me Google this. What did I say that was again? R65 is 75 volts against a 10K resistor. What's the voltage drop? Man, my pocket won't open and get my phone out. Come on, buddy. Okay, it needs to know more about it to figure out what the voltage drop across it would be. Okay, but so I have 75 volts, and then I have a resistor that's 10K, and then on this side I have 4 volts. This is the base side. So I have 4 volts on this side. I might take this capacitor off and check it. Because we already have found a bad capacitor on this board. Let's see what this reads. It reads 5.17 microfarad while it's a 4.7. 4.7 at 50 volt. I'm really thinking there's nothing wrong up here, and the thing that's wrong is whatever the voltage that the control unit's supposed to inject to turn it on. I think that's what's wrong. It's something down here on this board, and I'm not gonna be able to troubleshoot that, man. I'm just not gonna be able to. Like, how am I gonna find what's wrong on this massive board without a schematic? If anyone knows where I can find a schematic for a high-tech board like this, you don't, so your BJT might not have a problem. You might have current flow. You don't want to see 72 to 75 volts at your emitter. You're looking for current flow, not voltage at the emitter. Okay, so then my understanding of that is just bad. Okay, and that's totally can be the case. I could be 100% barking up the wrong tree here. 100% barking up the wrong tree. So, I don't understand how transistors work. That's the moral of this story. And that's, the transistor seems to be working fine. What I'm trying to figure out is why
my high voltage doesn't turn on, and I'm assuming my high voltage has to come in from that 75 volt. So that 75 volt has to make its way onto my main board somewhere, and then once it's there, it's being blocked before it can get to the flyback and all that goodness. Because the only thing I see on the base, the only thing I see on my hot transistor is 12 volt on the base, or on the middle leg, whatever the middle leg is. Yep, there's no schematics for this on the web anywhere. I could not find it. I can give you the model number of this PCB. Maybe one of you can... I was thinking literally about, because high tech still exists, I was thinking about taking a shot in the dark and messaging them and saying, hey, can I have this schematic from this board you guys made like a long time ago? Please? American Panda. Yeah, I understand what you're saying, man. So that is the part number for the video board, the video PCB. And I wish I could just find a smoking gun on this, like a bulging cap or a, you know, red hot IC. But no, there's nothing. It's just, and there's a video by Tronics Fix where he fixes this same exact thing, and he has the same problem where he turns the monitor on, and it just doesn't do anything. The light comes on in the front, but the picture never comes up, and he just throws it out and gets a new TV. He just says, I can't fix this. Even if I could, I'm not going to find parts for it. Throws it out. So that might be where we're at with this. I will have to see if I can, like if I look up this TV, can you buy one right now? I don't think you can. Nope. Jesus. Yeah, so Tronics Fix just buys a whole new television and installs it. Do you know an old man that repairs TVs? No, I don't. I don't. I wish I did. I might have to look around locally and see if there's a TV repair place that might still be in business, but I doubt it. I doubt it because people come to me to repair CRTs and I have no fucking idea what I'm doing. So if they're coming to me, you know they got nobody else. So... yeah, and the only other thing I could find on this board is that, like I said, on eBay, someone was trying to sell just this video board, but with all the wires cut for like $100. Has to be an old man. Yeah. Classic Tronics Fix. Yeah, that's what, and I mean, it worked for him. He just got another monochrome CRT and threw it in there, and it worked. And I mean, I can make this, I can fix this that way too if I just have him buy a new little TV. But yeah, I don't know. I just really wanted to get the original TV to work, but without any schematics, I mean, I feel like I'm just going to be sitting here and just like, unless I want to become Adrian's Digital Basement and just become an absolute legend overnight. But I need to get the model numbers off these ICs and figure out what they're supposed to be doing, and then get the oscilloscope and probe them and see what they are doing. Because it might just be one of the ICs is bad. It could still just be a bad cap. I mean, I did find a shorted cap already. And that shorted cap did go into IC2 here. So IC2 could be bad because of the shorted cap. That could be the case. Yeah. The joke about him is that he does is replace broken stuff when working stuff and calls it fixed. I want to solve them. Replace the whole motherboard instead of fixed. Adrian would invent a part and fix it with that. Yep, he would. He'd be like, "Oh, I just invented this whole thing and just fixed it with that." Yeah, that guy's a freaking genius. I can't do that. I know my video for what you guys are looking at is so bad. So let me see what you're saying. Farm Tech, near the high voltage transformer. So the high voltage transformer's up here. That's it right there. Or do you mean near the high voltage transformer you have a gray round thing with yellow dot in it, a fuse? So we have two fuses right here and here on this board. And that's the only fuses I've found. There is some transistors on that board too. But all three, so this has 3 legs coming off of this board, and it's 12 volt, 75 volt, and ground. So I think this board works fine. I think there's nothing wrong here. So that voltage goes into this board, and that's when things get fucked. So, near the high voltage transformer, you have gray. Okay, so on the big board. Okay. On the big board. Near the high voltage transformer, you have a gray round thing with yellow dot. Trying to find a yellow dot. I don't see any yellow dots. So I'm assuming you're talking about this transistor. I mean transformer, because of the flyback high voltage transformer. Yeah, I'm not seeing what you're talking about. There's this guy. This is yellow, but it's just a connector for the monitor. Yeah, the flyback, yeah. There's the flyback. So we could also take the hot out and see if the hot is good. That was a pretty prominent question mark, because if the hot's bad, then this can happen, right? So we might think about taking the hot out, and we're off, yes. Just throwing it in our little tester, you know. you guys are saying. Oh, it's not this. This isn't the same as the board on eBay, huh? It's different. Okay. Yeah, I found that board on eBay and was looking at that and was like, ah, that's it. But you're saying it's a little different, huh? I'm going to disconnect power completely here. Let me see if I have a ball driver that small. Or not a ball driver, but a driver. Nut driver that small. Let's see, what are you? Smaller than that? Oh yeah, smaller than that. Okay. I need like little forceps or something. That isolates that. And then it's got a thermal pad. Yeah, I found one on eBay that's identical as well, I thought. But American Panda, isn't all the wires cut on it? Like they're all just... They cut every single wire on the damn thing. Very annoying. Very annoyingly. Okay, let's put that in the tester. Let's put that in our pipe and smoke it. BJT NPN. It's got a bunch of numbers on there. I assume that's good. I assume this thing would freak out if it was bad. So, yeah, I don't know, man. I don't know what to do here because there's no schematics or anything, and I'm just here shooting in the dark, pretty much. I don't know what else to do. And Tronics Fix gave up. He didn't even, well, he didn't even try to fix this. He just threw the damn thing away. So, if he thought it was way too hard
And this is what he does full time. Oh God, I can't even begin to think what this would be for me, you know? Is the name of the TV and the board manufacturer. They both say Hytron on them. They both say Hytron. That's tight. It's back in there. Yes, it is. Do you want to know why? Because here it is. That's where mine came out of too. That's why we want to fix this TV. Otherwise, I wouldn't give a shit about this shitty ass little monochrome CRT. But that's what fits in this. I mean, I can just get another monochrome CRT that takes in what's it called? I use them at work all the time. These little not BJT. They're you know, connectors, and just plug it in and yeah. So everything in this works fine. Oh, it stopped following me again. Will you follow me? Hello? It's great. It's... How does it lose me when I'm in the center of the frame?
There you go, buddy. Yeah, so this is for the game store, and the Game Boy works, the game works, the sound works. Now this one's a little... What the fuck, man? What is your deal? Come over here. Thank you. Mine's a lot different than Tronic's Fix. Tronic's Fix, his video, he has audio and video going into the Display Boy circuit in here, and I only have video in mine, and mine has this little board that says Frank Mayer, and it says audio amp designed in 1992. And that takes the sound from the Game Boy and puts it out to 2 speakers right here on the inside. So the sound doesn't go through the Display Boy circuit at all in mine. It just goes right into this amplifier and then through the speakers. So the only thing going into the Display Boy is the video signal itself. So, and you know, at first, yeah, it's nowhere to be found. At first, I thought, okay, well, maybe this like CRT doesn't turn on if there's no video signal. And Tronic's Fix kind of messes with that a tiny bit with when he gets his new one. But I should at least, I assume, hear the high voltage crackle and hear the flyback boot. Like, I should hear the high voltage turn on, and I should have static on the CRT. If I turn the contrast all the way up, I should see raster on the screen. If it's anything like an arcade CRT. So, yeah, that's where I'm at. And I'd love to get the folks at the Save the CRTs to help me figure this thing out and save it. But I made a post on their Facebook group, and literally nobody answered me, as expected. No one. When I was trying to fix a Toshiba, like a pretty cool Toshiba, I did the same thing on there. No one said a fucking word to me. So, oh no, that wasn't the Toshiba. Someone actually responded to me on that one because it was like a consumer TV that they actually knew something about. What one was it? It was I had a VCR CRT that would go out after like 2 seconds of use, and we couldn't figure it out. And I posted it on there, and no one answered me there. So, yeah, I'm making a big assumption that. Well, actually, yeah, I'm making a big assumption that the CRT should turn on even if it doesn't have a signal. Maybe this CRT has something where if it doesn't get a signal, it doesn't turn on, and my problem isn't even in the CRT, it's in the console where it's not getting a video signal. But, I don't know. I just don't know. So... yeah. So, I'll probably I gotta make some posts for Missile Command because I'm stuck on Missile Command. I'm gonna make some posts for this somewhere. If any of you guys have any idea where I could ask questions about this CRT, let me know because I have no idea what groups to ask. Sorry, this chair's really loud. On this stuff, come on. You stop following me again? On the arcades, it's easy for me to decide who I'm going to ask questions to because, whoa, where are you going, buddy? Buster Brown, what are you doing? Just sit right here. Right there, young man. So on Missile Command, it's very easy for me to know who to ask questions to because I can just go on Museum of the Game forums and just ask people. This thing looked like hell. We got the new overlay on it. I've been recording a YouTube video for the restoration of this, and it's almost done. And right when I was doing the final touches of it, my logic board went out. Of fucking course it did. So everything, the monitor's recapped, the monitor works great. The monitor didn't work at all before we got our hands on it. But the game board worked fine. We plugged it in and everything worked. And oh yes, we won't have to do that much work to this. And then we get to the very end and we plug it in and it has no sound. And I go, oh, okay, I know how to fix that. I replace the op amp, I have sound again. And then I play it for like an hour and the board goes out and it's never came back on since. So yeah, this cabinet needed a lot of woodwork too. We had to do a lot of woodwork to it because this side was bowed out real bad and it was in a wet basement, so I had to redo the whole bottom part. We bondoed and sanded the whole bottom part. Yeah. Anyways, make this go back to me, I guess. I think I'm done for tonight because I'm going to go make a bunch of forum posts on why I can't fix anything. And I'm going to cry for help if anyone can help me fix any of this. So, yeah, that's probably my next course of action. Oh, Yank, power went out. Well, you're just in time to say goodbye because I think I'm going to get off. Next time, I'll probably stream tomorrow, but we'll probably do a bunch of consoles. Probably not out here in the barn because I don't think I'll have enough answers by tomorrow to continue working on this stuff. So we will come back to this once I have somebody or something that, wants to try to fix this. Maybe I reach out to Tronix Fix and say, hey, I have the same CRT and I know you wanted to put the original one back in yours. Do you want to try to fix this? Maybe we try that. Maybe we try it. I don't know. Don't know. Maybe. Don't know. Maybe. Maybe he says, maybe he answers me. Maybe. I saw there's one Facebook post that someone made asking about this exact CRT because he also had a Game Boy kiosk where it didn't work. And the only comment that was kind of helpful was, hey, Hytron still exists. Maybe message them and ask for the information. Maybe they still have it. So maybe I do that too as a shot in the dark. Maybe I use my, fancy corporate email to maybe get their attention, maybe. Maybe we do that, maybe. I don't know. Maybe we do. Okay, well, I want to thank you all for hanging out in the barn. If you're new here, we kind of split the stream into two sections. Sometimes we're out here in the barn where we work on the big stuff that I don't want to lug into the basement, like Missile Command and Galaxian and jukeboxes and Game Boy kiosks and all the big stuff like that. And when we're not doing this type of stuff, we are in the basement. And when we're in the basement, we're fixing PlayStation 1, 2, 3s, 4s, 5s, Dreamcast, old computers like Macintoshes, everything else that's small enough to lug down there in the air conditioning and in the nice area. We do that for very obvious reasons. So I'm trying to get this area more set up. I have it insulated now. I just need to get HVAC, and then I'll be able to be out here all the time. And we only have to decide which way we want to go just based on what we want to work on, not based on the current weather conditions of the outside environment. So. Is that the type with green phosphor monitor? I know Hytron made high and low end monitors for security systems and sold a few under Honeywell name. Also look for the SAMs on it. Yes, this is a green phosphor monitor because it's supposed to look just like the Game Boy. It is green. It is a green phosphor high-tech CRT, Hytron CRT, Troy Dog. That is 100% what it is. So Honeywell, the Honeywell name. So Troy Dog, I am gonna, while I got you guys all held captive here. So green. Ooh, Honeywell HMC14. Open the link. That's not green phosphor. You piece of shit. That is a security monitor, but it's color. Nothing's much coming up. Thank you for subscribing, Sensei Pandu. Sensei Pandu. I bet it needs a video signal to turn on if it was on display in a store. They wouldn't want a screen with static on it. Maybe. I can get a composite signal and put it into the in and put it all back together and see if it comes on. And then we know that the issue isn't in this, it's in that. But Tronics Fix had the same exact issue. Oh, I figured. Since I figured we have American Panda in here, I figured Sensei Pandu was the same person. It's funny. So the old Apple monitors were monochrome green phosphor. What is this, a 12-inch tube? I mean, I do have some other old one signal in monochrome CRTs, but I think they're different tube sizes. I think it's the oscillator chip, 15.6 kilohertz, that drives the transistor that is dead. TDA or LAIC. Well, here, let me tell you what the chips are. So there's two chips on it. I'm pretty sure it is an LA. Yes? Oh my god, that is so faded. It is so hard to read. That looks like it is a AN5763. AN5763. So that's an original Panasonic chip. And then, so I take a screenshot of that so I know what it is. And the other chip, there's two ICs on this. The other IC does not have a heat sink, and it is a AN5753. So we have a 5763 and a 5753. So that is the signal processing circuit, the 5753, and we don't have a signal coming into it. So I don't think that matters. I could plug the input back in and give it a signal and see if it really... Do you guys think there's any planet, like what Matthew says, where if there's no signal, it doesn't do anything, it doesn't turn on? I really don't think that's a thing, but I guess it could be. I think when I read the comments on the Tronics Fix video, that wasn't a thing. I think it should just be on and at least have raster if I turn the... Yeah, I found a small cap that was on IC2, on one of the legs of IC2 that was shorted to ground. I did. And I replaced it. So that was a thing. Okay. So I can plug that in and I can go get like a Wii or something, or like a some console and plug in a composite into the input and plug the input line in and see if it turns on. It really seemed like when Tronics Fix was trying to do it, because people said the same thing to him, like, "Oh, you don't have a video signal," and he said, "I tried that, it didn't work. That didn't change anything." So I am skeptical that that will change anything for us, but I'm willing to try literally anything if it will help us in our journey here. So there we go, that's plugged into that now. So I have this guy, and this guy plugs in here. That's going to be in. And I'll have to get a signal in. They don't want you to fix it. Yeah, I know. Most still power on. I agree. I think it should power on. So the cap that was shorted is attached to the 5753. Yeah, you're right. It is. It's this cap right here. It's attached to the 5753. But would the 5753 stop the high voltage from turning on? I don't think so. It's just horizontal deflection. That's just part of the circuit that puts the signal onto the monitor. Okay, our AI overlord says high voltage is not generated by the main power supply. Instead, it is created by the flyback, which relies entirely on a pulsing horizontal drive signal to function. Because the AN5753 is the source of that horizontal drive signal, its failure halts the entire process. So this is the heartbeat of the deflection system. Pin 7 of the 5753 datasheet is a horizontal drive output. If the internal horizontal oscillator inside the chip fails, no pulse is sent to the horizontal driver in the output transistors. Okay, so what pin is the pulse on? The horizontal drive pulse's output is pin 7 of that chip. So we can probe that with the oscilloscope. Let's see here. Okay, where can I get ground? So what pin on that is ground? Pin 5. Okay, that's all plugged in. That's all. Nothing is in a way that it's going to freak out. So we want to be AC coupling, not DC coupling. Thank you. Okay. We want to plug this in. Like that. Everything else is as it should be. As it should be. That is not touching anything else. 987, that is the correct pin. We have it on that too. That is on 5. No valid signal detected. If you don't hear a hum, it's not making the 15.6. Okay. I can see that. We have now experimentally proved that. What it needs is a steady 12 volts on pin 6. Without the 12 volts, the oscillator does not turn on. Okay, so let's see if we have 12 volts at pin 6. So those look good. Everything else looks good. We can turn it back on. That's not a good way to do it. Let's do it with this multimeter so we can see clips. Let me change your guys' screen too, since we're still fucking with this. What the hell? That was running away. Oh, that's millivolts. There we go. Okay, if that's truly where the 12 volt's supposed to be on pin 5, it's definitely not there. If my AI overlord is to be believed... and that, where it thinks the 12 volt line should be, that is where my shorted cap was. Yeah, so pin 6, so 9876, that we're attached to here, should be 12 volt. And then pin 5 is our ground reference. And I'm not seeing 12 volt there at all. I'm seeing nothing there. Okay, so we're gonna take a screenshot of what Troy Dog said. We're gonna go look that up. And I'm going to look up the pinout for this chip and not just trust AI. But that is the... $2573. $57.53. So here's the data sheet. Show me the data sheet. VCC is supposed to be on pin 6. Video input on 1 and 2. H hold is supposed to go out on 8. Is this AC? No way, right? This chip has to run on DC, I would assume. Yeah, there's no AC there either. So let's see. VCC 13.2 volt. Doesn't say. So the supply voltage is rated for 13.2. VCC characteristics total circuit current 11 volt. And so I don't see anything there. I don't see any voltage at all. So that is definitely a problem. So R48. R48 is our massive resistor that we already measured as 100 ohm. Oh no, we're not going through that. We're going through R40 right next to him. R40. R40 goes through a cap, and he comes up here, he goes around, and he comes out of that, goes over there, he actually comes out of the flyback, or he goes to the flyback. So what makes the 12 volt that's supposed to go into that chip? Does the flyback make that 12 volt? I can't imagine that's true. Let's see what you guys are saying. Near the B plus hot, you have E caps. 1, 10, 22, 47. Okay, let me unplug you. Near the flyback, I have a few caps. Yeah, I have quite a lot of caps. So, I mean, if you guys think that that's the best course of action for the next thing is just recap this whole board, we can do that. There is a lot of, you know, weird capacitors on here. There's these blue ones, these green ones, this giant orange one that I really don't know how to test in circuit or how to verify their condition. It could just be that one of them is blown, is open, and that's what's causing our missing our 12 volts on the IC over here. But 9876, yeah, so that's this line that goes down here to this capacitor that we found was shorted, that we replaced. And then if we follow him up, he goes through a resistor, he goes through, and that is connected to where the big resistor is. So if we measure the resistance across that resistor, R40, $14K ohm. 14K ohm. Oh. Yeah, I'm not getting the 12 volt to that IC, so that's definitely one of our problems. It's definitely a problem. And why is that? Why is that, you dumb animal? There's our big resistor. There's H. H takes us back to this, which is our high voltage. Isn't that where our high voltage was on H? 1 second. 1 second, ladies and gentlemen. Okay, so plug that in, make sure we're all still good with not shorting anything. We are. Turn that on, put this to voltage. Right. So there's 12 volts on that guy. So I want to check between ground and H. 12 volt. Okay. Okay. So H comes in right here, 12 volt. It comes up here, it goes right here, 12 volt. It goes to R40, 12 volt. And then nothing on the other side of R40. So what? Why do we have no voltage on the other side? I think I'm gonna buy an IC2. I think I'm gonna buy a replacement IC2 and see, maybe there's an internal short in this IC that's pulling down the 12 volt line. Because I can't understand why there's nothing else connected in this line other than R40 that comes down and goes to pin 6, and also it goes down to this cap, and that cap goes to ground. So that's just to keep constant 12 volt on that chip, I assume. That's all that's for. And it's not doing that because, well, there's no signal there. So it's either being pulled down by an internal short in IC2, or R40's messed up. But if I measure R40, R40 measured fine. It measured maybe. $6K ohm. Measures 6K ohm. And if we look at the bands on it, look at the bands on it of our 6K ohm R40. It is, oh god, it does look like it got a little hot. Orange, gray, black, gold. Orange, gray, black, gold. So let me look up resist. What is the resistor colors for $6K ohm? Blue, black, red, and gold. That definitely don't start blue, it starts orange. Okay, let's take it off the board. Okay. Problem is, I don't know what this resistor's supposed to be. Thankfully, the color bands aren't too messed up, but still. Oh yeah, there's definitely a mark under that. That's not a shadow, right? Yeah, it's hot in the middle, that's for sure. It got burned. Let's see what the out of circuit one reads. Oh, that's bad! 38 mega ohm? Yeah, that's definitely bad. Wait just a damn minute. So this is orange, gray, black. Orange, gray, black, resistor. $38 ohm? Is this supposed to be 38 ohm? Is that orange? This is where I start to... I don't think it's supposed to be 41 mega ohm, I know that. Orange? What is that fucking color? Orange something black. Orange brown? That definitely looks like gray. Orange something black. Orange something black gold. Looks like gray to me. It's definitely orange. I know orange, that's my favorite color. Orange something black. $30 to $40 ohm. Okay. Let me see what I got. I got a bunch of resistors right here. Here's 30. Here's a bunch of 30s. Here's 43. How much of a difference is that going to make if it's a few off, you know? I don't know. So this is 34.9. So do we put this in here and give it a shot? See what happens? Turn our iron on. The cap is no longer shorted. I already fixed that. Gonna wait for our iron to heat up now. In anticipation. Okay. Now I need my cutters. Where are my cutters? Cut it, cut it, cut it. Where are my cutters at? Probably under this fucking CRT. There they are. Okay. Take your bets now that we fix this. Will it, 1, blow the fuse again? Will it, 2, this is the resistor that gives 12 volts to IC2. So, will it, 1, blow the fuse instantly? Will it, 2, explode into a million pieces? Let's unplug this so we can put it where we've been putting it, just in case it tries to pop off on us. No popping off on us, please. Okay, there we go. Okay, and it is in the off position. Okay. Okay. Will it A, blow the fuse? Will it B, explode into a million pieces? I'm changing all the options so now Russ looks like an asshole for thinking that it's gonna explode. Or will it C? I'm saying numbers and letters, I don't know. Will the CRT turn on? Okay. Let me make sure my solder job's good. It looks good. That's in there. We got that one out. So, okay. It's definitely orange something black, so I don't think we fucked that up too bad. But anyways, okay. This is the fuse you're going to be want to look at to see if it blows. Here we go. 3, 2, 1. Okay. We got a high voltage whine. But it was really fucking loud. It didn't sound good. So I turned it off right away. Do we want to just leave that on? That was really high pitched. What do I want to do there? That's different! That was definitely broken! We got a very high voltage whine on turn on there. That was really high pitched. Is that what's supposed to happen? I don't know. It sounded not happy though. The fuse looks happy, but we didn't leave it on for very long. Do we leave it on for longer and see what explodes? I don't know. But it made a high voltage whine. Well, I honestly was going to go in a long time ago and then we started making progress. So, do I want to leave it on for longer? I kind of want to do that off stream, so if something happens, you guys can't make fun of me for blowing it up. Oh, God. Okay, American Panda. We found a burnt up resistor in the 12-volt line for IC2. Okay? We have replaced that resistor, and I turned it on and heard a very high-pitched whine. But it didn't sound like a healthy CRT high-pitched whine. It sounded like, I hate life right now, what is happening whine. So, I turned it off right away. So, now I'm debating if I turn it on and leave it on and see what explodes, or what do I do? I don't know. But we did find a bad part. That resistor for the 12 volt for IC2 was definitely bad. It was burnt up, and it was because of that shorted capacitor, if I had to guess, which we have now fixed the shorted capacitor. It is out of the case, so it could just be louder. Yes, that could be true. Okay. Do I just leave this fucker on and see what happens? Oh, God. I mean, it can't get worse than it already is. It's broke. High frequency, Vicky. Yes, high frequency. Just like the CRT monitor. We replaced the cap a long time ago, yes. The first thing I did when I went through this board is I checked for shorts on all the caps, and I found that cap to be shorted, and I replaced it. Now, from that cap being shorted, I find that the resistor tied to said cap was burned up because of that short, I assume. So IC2 could still be bad because of that short on its power line. So I might still need to replace IC2. But everything else was getting 12 volt just fine. So send it, I guess. Make sure nothing... Now that we're going to have high voltage on this board, I definitely want to make sure that nothing's touching anything. This is in there good. Fantastic. It's not getting any of the signals from the front, which are the contrast and stuff. So that might be why it's really upset, because it's not connected to the front panel contrast wheels. Maybe we connect that. Can we? That's gonna have to make it so close. We'll have to put it all the way back in there to do that. So it's not connected to the contrast or the brightness or the V hold or the H hold, which might be why it's so upset. It probably needs the V hold and the H hold to not sound super pissed off. So let me disconnect power here, and let's see if we can rig it up to have those signals and also not short on anything. Okay. We also don't have it plugged into the video signal lines, but that shouldn't matter. I don't think it gives a shit about that, to turn on at least. So, okay. Okay. Let's see what we get. If we get an explosion. I feel like I need to put a fucking welding mask on, but I don't think anything that violent's gonna happen here, but still, it's scary. CRTs are scary. Especially when they're in metal chassis. Fucking people. Putting them in metal chassis. Scary metal chassis. Oh my god, it's on! It turned on! It has a single point in the middle of the CRT. Like it's just got it just has a bright blob in the middle. But holy fuck, it turned on. That's probably because the other signals aren't plugged in. That might be because my V and H aren't plugged in. I think we did it! I think we actually did it. Holy shit! I thought there was no way. A fucking resistor the size of... Look at that guy. So it was... Wow. That is fucking legendary. So now I get to put this whole CRT back in the case. Yeah, so I don't have vertical or horizontal plugged in, which is why I don't see... So I can probably plug those in. Let's be careful now because our caps are charged. Let's see, if I plug these in... keep it up like that. Okay. Now everything's plugged in besides the video input and the green light on the front of it that tells you if it's on or not, which is just 12 volt bullshit. Okay, let's see if I get a signal that other than... let's see if I get a signal. Make sure that's all. We don't want to short anything. Okay. It's on. It's on. I plugged it. Yeah, it's a white screen. It turns on. I don't know why. I think I have the contrast all the way up, but that fucking works. Holy shit. That is so fucking awesome. Now, what time is it? It's probably really late, huh? It's 11 o'clock? Well, okay. I was really wanting to make this a video where I, go through all this, but I guess stream is also fine because we fixed it and I can describe on a video how we did it. I can't believe it. Okay, now let's get it back in the case, I guess. And we have to tell Tronics Fix how to fix his. Yeah, let's end it on a good feeling. I like FarmTech's idea here. Let's end it on a good feeling for tonight. Oh, did my mouse die? Oh no, it's back, okay. Let's end it here. Tomorrow I can come out here with a fresh mind so I don't accidentally plug something in backwards or do some stupid shit. And put it all back together. I remember it was a bitch to get some of this cableage, back in, the button I have to get back in there, and that sucked. So I gotta get it all wired back up, but here, I'll show you guys. I think I can do this. You deserve this for helping me today. So. Ah! Okay. All right. Hold on. Everyone, relax. Come on. Give me a little bit more. There we go. Okay. So, if I go to this screen, you're going to see the CRT now. Okay? And if I plug it in, and I double check everything again, and we turn it on, there it is! There it is! Well, thanks to you, everybody, for hanging out. We now have a working tube. That we can put back in the Game Boy kiosk. How exciting is that? Yeah, I'll turn it on again for you. So there was a shorted cap, and there was that guy. Little resistor that burned out because of that. There he is. I don't know what they use these tubes in, but they used them in Game Boy kiosks. They're cheap as fuck monitors. So, yeah, don't worry, I'll be working on a in-depth video on this. I'm working on a lot of videos right now. I'm working on that video. Let me put you back to full face cam. Working on the Game Boy kiosk video. I'm working on the missile command video. And we found it. I can't believe we found it. So, yeah, I will get this put back in the kiosk tomorrow, probably, because I'm so excited I'm not going to be able to wait. Well, I'll have to get all this shit back in here, get it back in the kiosk, and that kiosk is going back to the game store. And it'll be one of the few probably in the world working with its original monitor. So, very cool. No, we can't. I have to go to bed. I have to work tomorrow. I can't. Farm Tech said this is a good place to stop. I completely agree on him because I know me. I'll start racing to put this together to test it, and I'll fuck something up, and I'll be in an awful mood. It's just not a good idea. It's just not a good idea. What's going on there? Oh, did that come up? Is that came up the side here and went like that? Yeah, that's what that did. Farm Tech is right. Thank you all for hanging out. I hope you have a great night. Have a great Friday. Happy Friday, everybody. And we'll see you. I'll probably I don't know if I'll put this all back together on stream, but I'll definitely be making a video on it. If it's late enough in the day, I probably do it on stream. We'll see. I don't know. But it works now. Thank you all for hanging out. Thank you, Vic, Sunshine. Thank you, Troy Dog, Matthew, Crazy. And thank you so much, American Panda, for your expertise in going through this with me. And for everyone's expertise. Russie's. Who else helped out? Farm Tech definitely helped out. You know, all of you in here at one point or another had something to say that helped us figure it out. So, very cool. I will put your gold star in. I'll go in there tonight and put it in. So, everyone, have a good night. We'll see you next time. All right. Good night, everyone.